We're continuing with probability, and you can see it says compound probability. So I will show you that, and we will talk about experimental probability. And stick around because I will also show you the homework and give you some helpful hints on some of it. Well, first, compound probability means find the probability of two things. So imagine this situation. The probability of spinning a C on the spinner and rolling a 1 on the cube. Now think of that. If I said, hey, you would win a prize if you would spin a C, you might think, all right, not bad. I see 2 C's on there. I say, oh, wait. You're only going to win a prize if you spin a C and roll a 1. Well, now it sounds like that probability just got smaller. Well, it did. But for right now, let me show you at least how to calculate that. So first, you find the probability of spinning a C. If you look at the spinner, there are 8 spaces, and there are 2 C's. So the probability of spinning a C is 2 out of 8. You could also call that 1/4. You could simplify. The probability of rolling a 1 is 1 out of 6. The probability of rolling any single number on the cube is always 1 out of 6. Actually, I will use the 1/4. Simplified. That's just that 1/8. So what I do is I just multiply my 2 probabilities. In fact, I'll write that up here. So we will multiply whenever we're looking for a compound probability. So 1/4 times 1/6, well, you just multiply numerators. 1 times 1, multiply denominators, 24. Now think of that. It's 1 out of 4 chance of spinning a C. That's actually 25% chance. 1 out of 6 chance of rolling a 1. But together, doing one and the other, 1 out of 24 chance. So the probability really drops there. So see if you can figure this one out. Probability of spinning an A and rolling an odd number. So this word and, we can even think of that. It's our multiplication. So spinning an A, let's go count our A's. 3 out of 8. Rolling an odd number, well, in any number cube like that, 3 of the numbers are odd, the 1, 3, and a 5. So that's 3 out of 6. So 3 out of 6 simplifies to 1/2. Well, let's multiply 3 times 1, 8 times 2. That's the probability. These are the answers of the compound probability situation. And one more to try it yourself, and then we'll check it. So spinning a D, on that spinner I only see one letter D, 1 out of 8. And rolling a number greater than 2, well, numbers greater than 2, we have the 3, the 4, the 5, and the 6. That's 4 numbers. 4 out of 6 simplifies to 2 out of 3 chance. And multiply, like I've been doing. Numerators, 2, denominators, 24. Now this will simplify. I can make that 1/12. So long story short, multiply your 2 probabilities for compound probability. Now experimental probability is a little different. The last assignment we did with probability, that was called theoretical probability. Like in theory, if you roll a number cube, what would be the probability of rolling a 4 or whatever. In experimental probability, you're finding the probability after an experiment took place. Okay? So it says to write them as a percent. We don't have to, but the first thing, we get our total. If we add these numbers, we get 25. So the probability of, see, this was a survey. These are survey results. Probability that someone said fruit in our survey, 8 out of 25. Now, if we write this as a percent, it is 32%. Okay, probability someone said pretzels. You see what I'm doing now? 3 out of 25. That's 12%. Probability that they said something that was not fruit, well, if fruit is 8, everything else is 17, because 8 plus 17 is 25. And again, You change it to a percent. Moving on, you see what I'm doing? You can try these three, then I'll just show you the assignment. We're done. Granola, 2 out of 25. That is 4%. Carrots, 5 out of 25. Again, that simplifies to 1/5, which is 20%. Now, granola or chips, that's 2 plus the 7, 9 out of 25 is 36%. So the assignment will start off with what we already learned, simple probability. Okay, the spinner. What's the probability of spinning a 3, spinning an 8, spinning a number that is not 4, etc.? This is like a review. Okay, here there are 10 cards. That's your denominator. What's the probability to letter M? How many M's are there? Over 10. So that's just a review. Then you see 3 compound probability questions with a spinner and a number cube. Very similar to what we just did in the notes. On the back is experimental probability. So here they rolled a number cube 80 times. This is what they got. 16 ones, 9 twos, and so on. So the experimental probability of rolling a 1 is not going to be 1 out of 6. It's going to be 16 out of your total because we're talking about this experiment. Okay, same over here. 72 marbles were in a bag. Someone drew marbles 30 times, and these are the results. Well, based on these results, how many marbles in a bag are gray? Well, 15 out of 30 were gray in the experiment. See if you can figure out about how many of the 72 would be gray. And finally, we have a spinner. It looks like an experiment took place. They spun it 20 times. Those are the results. Now notice it says, what is the experimental probability of spinning a 4? Not the theoretical probability, because that's just 1 out of 4. You're going to use the results of this experiment to answer that question. As always, message me if you have any questions.